Okay, so first we were working with simplifying expressions that were factors. Then we were working with simplifying expression that were terms. So with the factors, we also incorporated distributive property. Now we're gonna have a combination of both, where we're gonna be working with expressions that are terms, but within those terms, they also have factors. And based on the order of operation, PEMDAS, give you guys a little insight here. I do not like the acronym. Please excuse my dear Aunt Sally. Even though it's a great mnemonic for you to remember, Aunt Sally is not very explicit where she says that it could either be PEMDAS or PEDMAS, whichever is first. So if within your expression a division shows up first, you have to do that division first and then multiply. And if in your expression a multiplication shows up first, you have to do that multiplication and then divide. So, even also addition and subtraction can be done in the reverse. It's commutative. You can subtract first and then add. You can add or first, then subtract. So it all depends on the rules of signs. If you have two negative numbers that are terms, you're going to be adding. If you have a combination of negatives and positive terms, you're going to be performing subtraction, but you might need to add all the negatives first. And then it's a whole bunch of analysis with this order of operation. But to keep things simple, at least to keep it simple for my students, I always tell students what's really happening is that you are in order of operation, you're working with your factors first. So when you put something in parentheses, you create a factor, right? If I have A plus B, these are two terms. But if I put parentheses among them, I create it into a factor. That's how come we can do a multiplication of terms in the, let me just put C here, right? You can do a multiplication of terms by using that concept of distributive property, right? So parentheses make turn terms into factors. So you got to work with them first, right? Exponents simply means if we have x squared, this means I have two factors of x. This is x times x. So again, it's a factor. Division, you have to use factors to divide. Multiplication, you got to use factors to multiply. And addition and subtraction are terms. So basically, what you need to remember for order of operation is that operate on, especially for expressions. Because when you're doing the equations, you do the inverse order. All right? So for order of operation, you operate on factors first, then terms. So I usually give my students a quiz with this. I have a lot of fun with this when I get students to assess what's actually happening in the order of operation, and I give a quiz grade just seeing them boggle their minds to find out what really is happening. But now that I have this video and it's public, it's spoiler alert, haha. So I might not be giving that quiz anymore, or maybe I'll just be testing to see who see this video. Anyway, my point is that when working with the order of operation, you work with factors first, then terms. So my first video with simplifying expression, I treated factors. The second video, I treated terms. And now we're going to be doing a combination of where you will see terms, expression that involve terms, and within those terms there are factors. So in keeping with the order of operation, you have to work with your factors first. And if you look at this expression, how many terms do you see? Well, I hope you said two. One term, first term, second term, right? We cannot count 2x plus 7 as terms anymore because they're in parentheses. So they have become factors. What you have to know about terms is terms are really factors that are separated by plus and minus. So you cannot say 5x is also a factor. A lot of time students get really tempted. So for example, if I have a problem like let's try this one first. So I'm going to work a little backwards. So if I have a problem like this, students are extremely tempted to distribute the 9 to the terms inside this parentheses, right? Because of some creature of habit, thing. What you have to understand first is that these are two terms. You cannot apply the distributive property here only if you had 9 times 10x minus 4. You guys see the difference? They're not the same. They're not the same. That's supposed to be not equal to, let me write that properly. Not equal to 9 times 10x minus 4. They are not the same. This is one term in which it's two factors, a factor of 9 and a factor of 10x minus 4. Here we have two terms. We have a positive 9 term, and we have a negative 10x minus 4 term. And if you remember from my previous video, you can treat this as a negative 1, because this is one term. Or you can say this is the opposite of 10x minus 4. So just for the sake of semantics, a lot of you probably trained to treat this as one factor. So you have the factor negative 1 coming before the parentheses. And in keeping with the order of operation, we're going to perform the multiplication here, which is the distributive property. So this is 9 minus 1 times positive 10 is minus 10x. Negative 1 times negative 4 is positive 4. See what's happening there? Versus doing 90x minus 36. Right? That's wrong. Right? Because 9 and 10x minus 4 are not factors. 9 is a term by itself, and negative 10x minus 4 is a term by itself. So now here, after I've done my distributive property, which is a multiplication operation, now I can do my addition, keeping in the rule of PEMDAS, or subtraction, whichever it is. But I'm looking here at the only like terms. Remember, when we're adding or subtracting expressions, we can only add or subtract like terms. Please refer to the video with simplifying expression that are terms. So here, we only like terms we have are the two constants, 9 and positive 9 and positive 4. Since they're like signs, we add and keep the sign, right? Or if you want to write it in order of hierarchy, you can write the variable term first and then the constant term. Either one will be fine. All right, so let's do one more for the road. Let's do a really big, giant size one, where you really have to take your time. So here we go. We have an example that is 3x minus 2 bracket 4x minus 3 times minus. Ooh, look at this baby. Look at this baby. They're just trying to test your patience. Literally, take your time. Take your time. Start within the bracket. Within the bracket, there's an expression there. Use the order. Start within the parentheses. We're going to take our time and rewrite the terms in each step until you work them out. So here, I'm going to start right here. That's my first step. So here we go. So when I say start, take a look at it. Do I have anything that I can simplify in this parentheses? Nope. But I have a negative 3 factor outside of it, so I can apply my distributive property. So that would be negative 3 times a negative x will be positive 3x. Negative 3 times a negative 5 will be positive 15. I'm still within the bracket. Take your time. A lot of you will be tempted to distribute this too. Don't do it. You are prone to making mistakes. Not saying it's not possible, but don't do it. Simplify your expressions in bracket at a time. So I am going to simplify what's in that bracket. All right. I see I have common terms, like terms of 4x and 3x to give me 7x, because all I'm doing is adding their coefficients and keeping the variable factor. And now I can apply my distributive property because there's nothing more for me to simplify. So I'm going to use this negative 2 factor outside. Right? So that'll be negative 14x minus 30. And then I can see further that I have more terms to simplify. So I'm just going to work with the coefficient of positive 3 and negative 14. Unlike signs, when it's terms, subtract, keep the sign of the greater magnitude. Notice I use the word magnitude not to be fancy, because in reality, negative 14 is not bigger than positive 3. You owing the bank $14 is not you having more money than me who have $3 in my pocket. Okay? So negative 14 is a bigger number. I mean, a smaller number than positive 3. However, it's bigger in magnitude, meaning size. So when you're using the rules of sign when operating with terms, you subtract on like sign and keep the sign of the greater magnitude, not bigger number. It's not bigger in value. It's actually smaller in value, but it's greater in size. Okay? So just a little recap there on the rules of signs, or if you're watching this video for the first time or being introduced for the first time, it's an introduction of how to properly assess when subtracting negative and positive integers, and why we keep the sign of the greater magnitude. All right, I think that's it for now at this stage of the game. When it comes to simplifying expressions, that is going to be a combination of terms and factors.